Welcome to Physics World Online College for easy physics and for better performance in your exams. In our class of today, we shall be looking at velocity. This follows the last topic, speed. In fact, we will have to learn about the similarity and differences between speed and velocity. Please remember to share this class video with your friends in other places so that they too can benefit from the discussions we are having here. Now let's continue. We need to know the meaning or definition of speed, velocity. We need to know what is average or mean velocity. Likewise, what is uniform or constant velocity, and instantaneous or variable or non-uniform velocity. Now, we say that velocity is the time rate of change of displacement or the rate of change of displacement with time. Velocity is a vector quantity. What does that mean? Velocity has both magnitude and direction. In fact, we say velocity is speed measured in a given direction. So remember, we said speed is a scalar quantity. So once the speed has direction, it becomes what? Velocity. However, both velocity and speed share the same SI unit, which is meter per second. Let's write on those. I said velocity is defined as the time rate of change in displacement or we can say it is the rate of change of displacement with time. And I said it is a scalar, a vector quantity rather. Velocity is a vector quantity, meaning it has both numeric value and direction. I said also that velocity is speed measured in a given direction. Now, by formula or mathematically, velocity equals displacement over time. Velocity equals displacement over time, which means if the unit, SI unit of displacement is meter divided by the SI unit of time is second, then you are going to have meter per second written as this, or meter second raised to the power of -1, which is the same thing as meter per second. So I said the SI unit of velocity is meter per second. Remember, meter per second is not the only unit of velocity. Kilometer per hour is also a unit of velocity. Centimeter per second is also a unit of velocity. But the SI unit of velocity is meter per second. Take note of that. Now, we have average or mean velocity. Average or mean velocity is the total displacement over the total time. That is, by formula, average velocity, that is mathematically, average or mean velocity equals total displacement over total time. Once again, average velocity or mean velocity will have the same unit as velocity. Now, there is another formula we can use to determine the average velocity. Now, you know, in mathematics, when you have two numbers and you want to take the average of them or the mean of them, how do you achieve it? If I have two numbers, 1 and 4, and I want to obtain the mean of them, I will say 1 plus 4 divided by 2. If there are three numbers, let me add 1 here, 5. To get the average or the mean of the three numbers, 1, 4, 5, I will say 1 plus 4 plus 5, I will divide by what? 3. Now, let me apply it here, which means if I have two velocities, that is, I have one I will call the initial velocity of the body, u rather, and the final velocity of the body, v. Then, if I'm looking for the average velocity of this body, I will now say the initial velocity u plus the final velocity v and divide it by what? 2. So another formula for average or mean velocity is find initial velocity plus final velocity divided by 2. So look at the way I will represent this average or mean velocity. So I will say v bar is equal to initial velocity is u plus final velocity is v divided by 2. You have to take note of this formula. Why? It is one of the formulas you will use when you are discussing equations of motion. We use it to obtain the second equation of motion. Very important. So know that average or mean velocity is total displacement over total time. Likewise, average or mean velocity is the sum of the initial velocity and the final velocity divided by 2. So I want you to take note of that. Then, another information I would like you to note is, although we are learning here that speed and velocity are technically different, yet they share the same SI unit, which is meter per second. Going forward in questions, you are asked or you are given, speed and velocity are used interchangeably. So you can say the speed of the body or the velocity of the body. What am I saying? This formula I just established now, that this is average velocity, which is initial velocity plus final velocity, can also serve to represent average speed. So then I will now say average speed is initial speed plus final speed. So I said we will use velocity and speed interchangeably because of what they have in common, as I've established. However, technically, they are not the same, which is what we are also establishing, that velocity is displacement over time, whereas speed is distance over time. Velocity is a vector quantity. Speed is a scalar quantity. Those are the technical differences between them. However, since they share the same SI unit, which is meter per second, we can use them interchangeably. I hope that point is established. Next, we'll talk about the uniform or constant velocity. Like I told you in the previous class, I said whenever you hear uniform, it means something should come to your mind, which is equal. Now, we have said that velocity is displacement over time. Now, uniform or constant velocity is going to be equal displacement in equal time. So I said a body is said to be in uniform velocity when it covers equal displacement in equal time. No matter how small the time interval may be. Then, another way we can define this uniform or constant velocity is to say that the body, the rate of change of the displacement with time of that body is constant. In fact, that is why we also call it constant velocity. Or a body is said to be in uniform velocity when the time rate of change of displacement is constant. Remember, this means that the displacement is equal for every phase of the motion or journey. Likewise, the time to cover each displacement is also what? Equal for every phase of the journey. Now, we can also have a displacement time graph, which we can use to obtain the uniform or constant velocity. So if we have a displacement time graph, given or shown in the diagram, displacement in the vertical axis against time in the horizontal axis. The origin is 0, 0, and we have it as a straight line graph. Then the slope of this graph will represent the uniform or constant velocity. So I'm saying the slope or gradient of a straight line displacement time graph represents the uniform or constant velocity. I hope you follow the sequence. If you say distance time graph, then the slope will be uniform or constant speed. Then if you say displacement time graph, the slope will be what? Uniform or constant velocity. So I'm saying that is slope or gradient, which is the change in the displacement axis divided by the change in the time axis. Here it will represent what? Uniform or constant velocity. That is the point I'm establishing here. So take note of it. Those are common questions you are asked in exams. Next, we will talk about the instantaneous or variable or non-uniform velocity. Now, we said for the uniform velocity, the body have a straight line motion. However, for a variable velocity, the body will have what? A curve motion. So when the body is having a change of displacement with time that is not constant, that is not uniform, we call it variable velocity or non-uniform velocity. In such case, you can only determine the velocity at a particular time. You can only determine the velocity at a particular instant in time. When that is done, we call it instantaneous velocity. In fact, the speedometers of moving vehicles, of moving cars, records instantaneous velocity or instantaneous speed, because you use it to tell the speed of that car, the velocity of that car. Mind the way I'm using the word interchangeably now. Speed, velocity. The speedometer will tell you the speed of that moving car, the velocity of that moving car at a particular time, at a particular instant in time. I hope that point is noted. So I said variable or non-uniform speed, non-uniform velocity that a body is said to have a non-uniform speed when a non-uniform velocity, I mean to say, when the time rate of change of displacement is not constant. And I said, in such case, the velocity can only be determined at a particular instant in time. Hence, it is called what? Instantaneous velocity. The velocity of such body is determined at a particular instant in time. Hence, it is called the instantaneous velocity. Instantaneous velocity. Good. And the displacement time graph showing this variable non-uniform instantaneous velocity is represented as, so I will now have displacement. Once again, you will put the unit on the vertical against time on the horizontal. You put the unit as well. Origin is 0, 0. So because it is not uniform, then it will be a curve. It's not a straight line. In such case, you can only determine the instantaneous velocity at a particular point in time. So if this is point A, this is point B, this is point C, this is point D. So I can only get the velocity at a particular point. So if I want to get the velocity at point B, I will simply take the tangent, take a tangent at that point B, and then find the gradient at that point. So this will represent the change in the displacement, the change in the time. So the velocity I will get at point B is the instantaneous velocity at B. I hope you understand clearly. Now we are going to solve the example that we have. So I said the slope or gradient at point B represents the instantaneous velocity at point B. So that is by saying VB equals the change in the displacement axis divided by the change in the time axis. That will give us the instantaneous velocity at point B. That can be applied for each of the other points, point A, point C, point D. And I said, note that the speedometer of moving vehicles or cars records or indicates the instantaneous velocity. So in the absence of velocity, you can take instantaneous speed. Good and fine. So let's solve the example. Once again, all these velocity have the same unit as meter per second, SI unit, and other units such as kilometer per hour, centimeter per second. They are all units of velocity. Now let's take the example. A bus travels 300 meters in 10 seconds. Find the average velocity. Good and fine. So solution to example. From the question, we are given that the displacement, because this is velocity, we take this as the displacement. We are given the displacement D as 300 meters. And then we are given the time T as 10 seconds. So for us to find the average velocity, we will say the distance over the time, the displacement rather, over the time. So observe that I'm using average velocity, I say displacement over time. It is the same thing as saying total displacement over total time, because we have just one mentioned distance and one mentioned time. So this gives us displacement in value is what? 300 meters, and the time is what? 10 seconds. If you divide 300 by 10, you have 30 meters per second. Good. Probably I should also show you how you can convert from meter per second to kilometer per hour. Let me add that here. So observe that this question gave us the displacement in meter and the time in second. So I now found the average speed or speed in meter per second directly. I didn't have to convert. Since the displacement is in meter, the time is in second, I didn't have to convert. I just solved directly and obtained my velocity in meter per second. This is different from the previous one where, okay, from this, where they give you the displacement in what? Kilometer, the time in what? Hour. There, you can first convert, obtain the velocity in kilometer per hour. Then you convert to meter per second. Or you convert this kilometer to meter first, convert this hour to second first, then you now divide in meter per second. Now, I want to show you that you can also convert from meter per second to kilometer per hour. So let me assume that I'm looking for the velocity or average velocity in kilometer per hour. Okay, let me take this now as option A. So let this be what? Option B. Now this option B is conversion from meter per second to what? Kilometer per hour. So that's doing it the reverse way. So how will you achieve that? It's very simple. We already now know we are reversing the operation we did previously. So I'm not saying that average velocity which we have obtained as 30 meters per second. So see what I will do now. I will take 30 times. I will multiply it by 60 times 60. And then divide it by what? 1,000 kilometers. 1,000. So by multiplying by 60 times 60 and dividing by 1,000, I will convert it to what? Kilometer per hour. So this zero cancel this zero, this zero cancel this zero, this zero cancel this zero. So I have 36 multiplied by 3. So 36 times 3, that will give me 18, 1, 9, 10, 108. So I have 108 kilometer per hour. Do you see that? So it's a very simple thing to do. If you are converting from kilometer per hour to meter per second, you multiply by 1,000, you divide by 60 times 60. If you are converting from meter per second to kilometer per hour, you now reverse it. You multiply by 60 times 60 and divide by what? 1,000. I think that is a very good place to end it. Please do this assignment 1 and 2. I always say, once an equation has been given to you, you can be asked to look for any quantity. You make that quantity the subject of the formula. So if you check this second question here, they gave us the average velocity and gave us the distance. They say find how long. How long means time. So to find the time, you will make the time the subject of the formula, which means if you make time the subject of formula here, you will have displacement divided by what? Average speed, or displacement divided by speed, average velocity. If you do that, you will obtain the correct answer for this question. So please solve this assignment and submit to me. I see you in the next class. Bye.